Um, okay, we're all set. Good afternoon, everyone, and welcome to the session hosted by SSO Digital Solutions. And as you guys know, my name is Jayden Reo, and I'm the founder at SSO Artist Entertainment. And today's presentation is part of our continuing technical development series, which is basically an initiative where we're exploring the deeper probabilistic and computational systems behind our infrastructure. So the topic we're going to go over today is the probabilistic engines, which is more specifically Monte Carlo systems and applied Bayesian computing at SSO Digital Solutions. So over the next half hour, we're going to dive into the mathematics, architecture, deployment of probabilistic models, and stochastics within the ARDnDeX API, including Monte Carlo, Markov Chain Monte Carlo, quasi Monte Carlo, Bayesian inference, and sequential particle filters, and how these principles underpin applications in medicine, finance, AI, digital pipeline validation, and pretty much any other facet it could be implemented into. So this talk is going to be both conceptual and operational. So I'm going to start off by discussing how probabilistic logic isn't just a mathematical framework, and how it's an engineering mindset that defines SSO's approach to automation, compliance, creative infrastructure. And with that, we're going to begin probabilistic mindset. So essentially, every system, digital, biological, or social, it's an argument with uncertainty. So at SSO Digital Solutions, we don't see randomness as a limiting factor. We're actually tuning into different probabilistic methods to eliminate any margin of error that can come with pretty much any facet of running an ecosystem, particularly a digital ecosystem. So that's definitely part of our design. And basically, we're going to talk about Monte Carlo to start with. So pretty much Monte Carlo methods they're basically a normal distribution approximation method that approximate the intractable. So essentially, they let us see a function that you can't normally express analytically. In essence, it's sample, average, converge, and at SSO, our validator architecture, which is the ARDnDeX, we use Monte Carlo and quasi Monte Carlo sampling to test the resilience of metadata digital payloads against distribution variance and pretty much hard set standards, especially DDEX and the different digital infrastructures that we propagate our content to. So essentially we perform parameter sampling across metadata drift, timing jitter, and digital streaming platform specific tolerances. So something we've particularly been using a lot more than regular in our ARDnDeX infrastructure is the Sobol and Halton sequences. So they're deterministic, but low discrepancy in nature, which allows it to ensure edge cases are covered replicably and reproducibly. So in probability theory terms, this is risk propagation, but in an audio technical context, instead of estimating integrals, we're estimating failure likelihood. So for example, one of our high usage implementations of the ARDnDeX infrastructure is the failure likelihood and rejection probabilities against set standards like DDEX. So example, a DDEX package that we're sending media, for example, to Netflix, to Apple Music, to Spotify, or to essentially any DDEX recipient. So basically with the ARDnDeX, we're predicting the rejection probabilities, severity scores, and candidate root causes. So the result is pretty much a statistical immune system for a distribution network. Now, this can very well be implemented into a multitude of other facets of technology. Now, this isn't just for music. Particularly, we're using it for music in our media side, but in our SSO Digital Solutions, we're rolling this out over the next year and the next few years. We're rolling out different digital solutions, starting with some executables. They're going to work Windows, Linux, Mac, even Chrome OS we're implementing, since they have pretty good webhook through Google, pretty good webhooks for APIs, and good Python handling. They're just not the most powerful computers, but very doable if it's externally located on servers, which is definitely a huge area for implementation. This can be implemented into a literal app on your phone. Now, circling back to Monte Carlo and more stochastic modeling things, we've also been looking at Markov Chain, which from Markov Chain, Monte Carlo, and Bayesian learning loop. So you've probably heard of Bayesian bandits. So essentially, the Markov Chain Monte Carlo adds memory to it. It's turning basically a guided walk into like a guided exploration. And this is not just, generating a probability based off of a random, deemed unpredictable outcome of something. Since let's say in the case of, data infrastructure. Now, when we're sending a DDEX package, as long as it aligns with DDEX's standards, it will be submittable. Now, for example, Apple, Spotify, Tidal, they have definitely stricter, standards and guidelines, and definitely some other media and metadata that could be added through additional metadata in the DDEX, ERN, or the MEAD. So essentially in the ARDnDeX APIs that we're implementing, we can use Markov Chain Monte Carlo as a convergence mechanism. So not just for inference, but for iterative policy learning. So you can imagine the validator is an adaptive sampler. Each state is going to represent a validation rule, and the transitions are going to represent passes or fails. So essentially, in layman's terms, against the DDEX, we know that if we're matching the thing, the DDEX's set of standards, it'll be submittable. But to the other platforms like Apple, we cannot predict it. Now, basically, we're representing this in our system. We're flagging it internally as a pass or fail. Now, a fail would be that either it's not gonna even pass DDEX standards, or at least it's not gonna pass Apple, Spotify, and definitely there's more metadata and reasoning behind it that we're building into it. So this isn't just a pass fail, but essentially at face value, superficially our system just shows pass fail. That's an internal marker. And over time, the posterior probabilities of failure updated prior. So it's a Bayesian feedback loop built into the Markov Chain Monte Carlo, which is great because these standards change and there's always some element of unknown, since Apple and these other platforms do not publish their exact internal standards of their validators. And this can be applied to pretty much anything else, any technical solution. So not just media. Now, this can be AI. Now, the probability that an answer will be correct is already built into the schemata of AI, like OpenAI's ChatGPT. We look at Google Gemini, all these other AI giants right now. They all have some sort of internal schemata that is determining whether it's a good or not answer, the best answer. But if we build this into the AI, we can get, especially for more technical, like economics, finance, when we build more specific AI tools, like for finance, you might have an AI finance tool that is in the future going to facilitate the prediction of financial outcomes. Now, whether it be stocks, company deals, showing risk management. We already are implementing Monte Carlo, but for AI tool, designed with Monte Carlo and especially a Bayesian learning loop, which is building upon the schemata and basically is factoring in the ability for like AI to do the simulation and accommodation built into the schemata, and making it appear over time as a more accurate results. And it's not abstract. It directly shapes the policy that YML is implemented into Apple, Spotify, Tidal. They pretty much govern the packaging and delivery. So if we're talking again about like the digital delivery of metadata, this is very, very, very useful. So talking back to the Monte Carlo Markov chains, we can model this as the probability of theta given d, which is a representative variable that's representing prior, essentially, is equal to the probability of d given theta times the probability of theta or the probability of d. And we're letting the data from each ingestion, success or anomaly, refine the priors. That's the Bayesian learning loop. And the Bayesian filters also underlie our anomaly detectors. So, for example, one particular instance that we see this come up with a lot and has been very, very beneficial to our internal algorithms is, our time series streaming analytics module using posterior updates to detect outliers beyond, credible intervals. So, like low frequency, high impact events that a deterministic system would miss. For example, we look at, basic, analytics. Some of you can see user retention. Now, for example, we can look at a statistic showing that 34% of listeners on this particular song, album, whatever, let's just say song, listened to the whole thing. The rest stopped it at some point and did not finish the song. At least not a statistically significant portion of the song. Now, that does not factor in other variables. Now, this allows us to show it in, context of other factors. Now, for example, maybe the reason why these listeners are not fully listening to it, only 34% listen to it fully, could be because that is the same day that a extremely popular or anticipated album has been dropped. It could be a multitude of other factors. Now, this shows that in context, in a higher frequency of occurrences, so across other data, essentially we see that across our entire catalog or across an entire specific label that we cater to's catalog, we can see that, across the catalog, 50% listen to the whole thing. 50% of listeners listen to the entire song. Now, this is higher than that 30%, but you can see the outliers, and obviously that 30% is an outlier, but a simple analytic system, like showing, on these simple analytics systems, like, let's say you're using a simple distributor, like, DistroKid, a lot of people use when they're first starting off. That's only going to show you, like, the time that they listen, percent that they listen through it. It does not show these other things, and it does not determine whether it's an outlier or not, and the Markov Chain, Monte Carlo, and Bayesian learning loops are definitely going to help facilitate this. And we're looking at some, quasi Monte Carlo, QMC, sequential particle systems. In SSO's architecture, what we've been doing is using quasi Monte Carlo to actually cover every single parameter space of digital streaming platform metadata, every field, tolerance, possible encoding variant, and instead of thousands of random points, we're creating a deterministic grid that guarantees coverage. So our quasi Monte Carlo is essentially what is gluing together our ARDnDeX infrastructure. And particle filters extend this to time-evolving systems. So in Bayesian language, they're approximating the posterior distribution of a latent state sequence given observations. And in our pipeline governance, particle filtering lets us track metadata consistency as a dynamic process. So where each new delivery, validation, or correction represents a new observation. So the ARDnDeX probabilistic kernel updates its belief about the system's integrity continuously on the cloud, which is a huge point of our, new features that we're rolling out to our pipeline in 2026. So SSO ARDnDeX, the API as a probabilistic engine is bounds above any other cloud-based API, I believe, at least for statistical modeling. So what is ARDnDeX? You may be asking. I've been talking about it this entire time. So it's a digital, schemata, basically AI-based, however not particularly. We'll get into that later. It's a command line tool, digital executable, and an API service in our servers that integrates our entire infrastructure and ecosystem, and it's built on top of Monte Carlo and Bayesian inference core, and is, like I said, glued together by the quasi Monte Carlo and sequential particle systems. And it's powering validation, error prediction, governance across the SSO network, and basically, since it is cloud-based, the speed and ability to implement this into any program, not even just an SSO, makes it very valuable for a lot of different companies, statistics, medicine, etc., like I've spoken about. And the ARDnDeX engine consumes structured metadata like MEAD payloads containing ISRC, UPC, Dolby audio definition model or ADM details, and validates them through a probabilistic lens. So every XML, JSON, or YAML, which is what we use a lot, it's very, structured and schematic based, and is very good for, AI cross compatibility, which we're implementing also, or pretty much, metadata payloads become a data point posterior distribution of reliability. So conceptually, each command line runs as a simulation. So for example, one of our implementations, you can use it if we're using like a command line tool, or our system internally is we do the the command line run SSO validate -- release SSO _ 2025 _ 0000341. Now this is just we're looking at an internal SSO release code. Now this is referring to just a random release. -- Monte Carlo 100,000. Now this is running the Monte Carlo with 100,000 iterations. And then -- kernel Bayesian. So we're gonna read that again. The SSO validate -- release SSO _ 2025. Whatever the release code is. -- MC, which is Monte Carlo, and 100,000 kernel Bayesian. So it's running the Monte Carlo with the Bayesian, and the fact that this can be added to a analytics, it's just one simple command line that can be added to a executable program in any instance. So basically, it's implementing our API, the validation APIs, into any other program or area of metadata handling, processing, uploading, etc., ingestion. And this is one of the main features of SSO ARDnDeX. And this tool runs 1 million Monte Carlo iterations by default, and it computes failure probabilities and writes a posterior audit object, which is the Bayesian, the Bayesian learning loop. And each posterior then feeds our governance layer, like I said, refining policy packs for Apple, Spotify, YouTube compliance. So in practice, it's an ecosystem of Bayesian feedback. Now this application can be used across multiple technological disciplines. And, probabilistic software is pretty much universal. So in medicine, the same Monte Carlo and Bayesian engines drive radiology, reconstruction, dose response systems, and uncertainty quantification and bioinformatics. So SSO's architecture could and, likely will adapt to medical imaging, QC, validating DICOM metadata, or predicting failure in hospital PACS transfers. So, in finance, these models translate to portfolio risk management, value at risk, stochastic volatility, Bayesian hierarchical models for market regimes. ARDnDeX's kernel, which is already tuned for deterministic reproducibility and high dimensional sampling, can simulate correlated market paths. And it's very applicable across, low dimensional samples, since it's built to handle high dimensional samples. It's extremely fast, faster than any simple, Python modeling. So an AI Monte Carlo drop-in and Bayesian neural networks mirror these concepts. So stochastic approximations of epistemic uncertainty, and in digital pipeline validation, ARDnDeX ensures that the data flowing through the systems for mastering metadata, royalty, analytics, it stays statistically consistent, self-auditing, and explainable. So in an era of algorithmic opacity, which we're currently in, there's so many different clashing implementations across different disciplines of technology. Probabilistic explainability is at this point ethical infrastructure, and definitely will set a standard for AI tools in the future, I think. So as we look ahead for the future of probabilistic design, and specifically SSO probabilistic frameworks, it's that they're not just technical innovations, and they're cultural ones. So automation as culture means which is something we're focusing on. It means every standard, every rule, every sample is part of a self-learning society. So Monte Carlo isn't just a computational technique. It's a philosophy. It's a belief that randomness can be disciplined, uncertainty can be understood, and probability is the purest form of truth. So this has been Probabilistic Engines, presented by SSO Digital Solutions. So we're now going to open the floor for questions from both our technical committee and invited investors. So fast forwarding after the deep dive, excuse me. Our data systems committee member, Michael, asked us, let me look at the question. How exactly does ARDnDeX API handle variance across digital streaming platform metadata formats without revalidating its higher payloads each time? Yeah, good question. So we use a differential-based resubmission protocol. So every validation run stores a canonical signature of the payload structure, and refeeds that into the Bayesian loops, and it's derived from the mean and error and hashes. So when only partial feeds change, ARDnDeX just resimulates the affected parameters using a quasi Monte Carlo kernel. So it's deterministic, cached, and state aware, which reduces compute by nearly 70% across partner integrations. And we've even seen when structured using the APIs that we can even get compute reductions up to 82%, since we're implementing a cloud-based computation system into a smaller one. Okay, we're looking at our applied mathematical committee, and we have a question from another Michael, different one. Okay, so we see that he mentioned okay, so he's asking whether Bayesian feedback loops are static or if they update in real time during ingestion. So yeah, good question too. They're adaptive. So the posterior updates continuously as new evidence enters the validator pipeline. So each ingest event modifies a live prior using a conjugate model. So that's how our system learns which metadata delta statistically precede rejections or success outcomes. So the priors aren't reinitialized per job. They evolve with our historical probability landscape. So essentially, there's immediate, updates if it's critical, but it also gets moved into our validator pipeline, which takes about 2 to 3 hours to process, and after 12 hours will be fully implemented into, newer applications of the API and computations. So So we're looking at Vanguard Technology Partners, which is one of our investors. So the question is, what does SSO's 2026 plan look like in terms of product expansion? And he asked, are you positioning ARDnDeX as strictly as an internal validator, or will it scale outward? So yeah, 2026 with our 2026 plan is when ARDnDeX transitions from an internal infrastructure to a more public-facing probabilistic services platform. So, like we've said before, I'm just going to reiterate a little more cohesively. The plan has three pillars for at least for ARDnDeX. So they're going to be external API commercialization. So that's when we're offering our validation and probabilistic audit engines as software as a service for creative, medical, and fintech ecosystems and analytical based platforms. Second pillar, adaptive AI compliance layer. So we're basically adding a meta validator that can plug into third-party data pipelines to certify integrity probabilistically. That's what I said, the command line excerpt that I gave you guys. The edge compute deployment is the third pillar. So basically, it's going to be a lightweight probabilistic agent running on localized nodes. That's our executable programs for near real-time anomaly prediction in digital media and regulated environments. But we've architected the stack so it scales elastically without compromising data provenance or deterministic, failures and passes in our system. So that's why the external API commercialization is extremely important. And when we're making this as a public facing probabilistic service platform, like we've mentioned, these are going to be three of the main services that we are going to offer. Now, it's not going to be available to every client, but when it drops, it's going to be a little more structured of how to implement this. So thank you for asking that question. So Apollo Group Capital asked, in risk management terms, how does Monte Carlo simulation translate into revenue, reliability, or reduction in rejection costs? Okay. Yeah, I would say, every rejection delivery costs us time, bandwidth, opportunity, so our Monte Carlo validator preemptively is estimating the probability of a failure before the payload ever reaches a digital streaming platform. So that's saving extreme amounts of computation and human time. So by sampling metadata, jitter, tolerance thresholds, we can quantify risk per release. So in 2024, that's when we first started implementing ARDnDeX internally. That saved 31% of distribution cycles. Now by 2026, we're planning, with our full Bayesian priors and reinforcement learning in place, we're projecting 40 to 45% reduction in rejection-related losses. So that's a huge step forward in our ARDnDeX risk management. That definitely translates into revenue, reliability, and definitely reduction in rejection costs. Because if we can, estimate the probability of a failure, we can essentially fix it before it even introduces a later problem, and there'll be, a huge area for application into different facets. This isn't just music. This is any statistics, and this can apply to any facet of technology. So another committee member, just from our software engineering team, he chose not to put his name. Okay. How do you ensure reproducibility and probabilistic computations given the random seed problem? Okay, good question. Okay, so each simulation we run uses a fixed seed Sobel or Halton base, so it's essentially a deterministic system with quasi randomness, and we store every seed vector in the audit log, which later gets updated into our after 12 hours into our Bayesian loops and further implementations and applications of the ARDnDeX. So, essentially, that means any run can be reproduced bit for bit, including the noise model. So the philosophy we have here is that, that it's random behavior, but deterministic in accountability. So, again, this is why it's such a huge milestone for SSO Digital Solutions, is that this could really be applied to almost any facet. especially medicine, technology, definitely music. So from another one of our investors, Nova Analytics Fund, one of their investor chairmans asked, will the probabilistic framework apply to SSO's AI tools and creative analytics as well? So, again, glad you asked. That is part of our 2026 plan convergence roadmap. So the same inference kernel behind ARDnDeX will support probabilistic model validation for AI music generation, which is something we're looking into. Mastering recommendation systems and royalty forecasting. Essentially, the same mathematical DNA framework will govern every predictive layer of SSO's ARDnDeX. So good question. And one of our moderators is asking, what's the vision behind 2026? So, to kind of wrap everything together, SSO Digital Solutions are going to evolve into a probabilistic infrastructure company, and every system from, audio mastering, machine learning, governance is going to share one trait. They're going to reason under uncertainty of measurable confidence. So by 2026, we won't just validate data, we're going to validate trust. So, and, the application area of things where we're able to implement this into any solution and external clients that's definitely our vision, making this commercial. So, our senior systems engineer for our digital infrastructure, Sean, asked, can you elaborate on how ARDnDeX interfaces with SSO's CI/CD pipelines and the validator architecture? How are Monte Carlo simulations integrated into production rather than staying in a sandbox? CI/CD. Okay, got it. Okay, sorry. Good question too, actually. We embed the Monte Carlo kernels directly inside the CI/CD orchestrator as like a pre-flight hook, and this can even, for the APIs, be a webhook application. Basically, every commit triggers a probabilistic QC stage. It's gonna sample configurations, audio bit depths, metadata encodings, timing offsets, and to calculate an expected rejection probability. So if the posterior crosses a defined threshold, the pipeline is going to halt automatically. So uncertainty isn't like a post hoc, it's more built into our continuous integration itself. So, yeah. And our machine learning researcher team. Okay, you mentioned Bayesian detectors for anomaly detection. Are those supervised, unsupervised, or hybrid in design? They're hybrid. We're leaning towards unsupervised. We want these AI applications like OpenAI, Google Gemini to facilitate this in the future. We're definitely looking into cross integration with AI solutions, but we start in supervised, so we're using like basically Gaussian process priors and our Bayesian feedback loop priors over historical ingestion metrics. So once enough annotated anomalies accumulate, now this is like multiple releases coming from one label or aggregator that we're working with. We're going to transition it to a semi-supervised Bayesian network. So the posterior is then adapting dynamically, which each newly labeled instance. So think of it as like an evolving belief network that matures with our operational data. So if a problem occurs, the system's going to try to identify where the issue is coming from and annotate it internally so we can see what the issue is. And if the system isn't able to fix it, or if it keeps occurring, then our team's gonna step in, try to fix it, and re-implement it into our networks. So Omni Capital Ventures asked another question. So what is the projected financial model for ARDnDeX when it becomes public in 2026? Subscription, per query, or licensing? Okay, our model is gonna be tiered. We're gonna more on this when it comes out, but essentially we're gonna have enterprise SaaS for continuous probabilistic validation. That's more of a subscription service. that is going to be look different for every client, for every implementation, but that's for more continuous uses. Now there could be pure run compute credits for independent developers running Monte Carlo batches. So we're gonna work with that's gonna be for more for working with you know encoding houses, so that are a little bit smaller in uh, output volume. So it could be a little more cost effective for them. And there's gonna be on-prem licensing for medical fintech partners that require like regulatory isolation. So essentially, yeah, their data may not be trusted on our servers. We have high confidence in our servers that the data is spread and compartmentalized enough that security will be maintained even at the API implementation level with even AI. So definitely there's that if they want to just run a subscription. But all the tiers plug into a ARDnDeX compliant audit system that ensure data royalty traceability, and even just the Monte Carlo command line tools. So that could just be used however the client sees fit, medical, fintech, whatever. And yeah, so one more question. Our applied statistics committee member, Jesus, how does SSO ensure statistical convergence in its Monte Carlo pipeline, especially under parallel execution across GPU or clusters? We don't actually require parallel execution across GPU or clusters. It doesn't facilitate or, increase the at least speed or computational power, since a lot of it is cloud based in our servers, which are, thousands of GPUs built into it. This is not something that is going to put stress on, a particular device. That's why we say we can implement it using the APIs or however into any system. But most of it is, based in the SSO's network of servers. But let's say this is more of a medical or fintech partner that implementing the regulatory isolation that Omni Capital Ventures was kind of asking about. We're going to treat each node as like a quasi-independent sampler under a common random number stream. So Sobel sequence partitions are going to be deterministically assigned to GPU shards, so that variance reduction is going to scale linearly, and afterwards a recombination step is going to compute the Gelman-Rubin R hat statistic across all chains. So only if R is less than 1.02 that we declare convergence. So this ensures statistical validity at a distributed scale. So that R hat statistic, which is implementing the Gelman-Rubin stochastic model, that is one of our internal markers of whether something is a pass-fail, but this is more of a niche facet of it. So this is more looking, every combinations and some Sobel sequence statistical validity. But essentially that's not really going to need to happen, but it is definitely great that SSO is offering the flexibility of, hosting. And Atlas Digital Holdings, which currently is our second highest investor. What is the biggest technical risks for the 2026 plan? So, it's kind of funny. We used it, our program, ARDnDeX, and all of it to determine these risks. But we've also had private risk evaluators and advisors look at it. So we've kind of came up with the three main risks. We're mostly focusing on 1 and 2, but the third one, is there. So, model drift. As our partners are going to update ingestion schemas, our products can become stale. So We are mitigating that with automated schema diffing and continuous Bayesian recalibration, and especially because we're a committee member of ARDnDeX, we're essentially gonna know about the changes before they're even rolled out into a new DDEX standard version. So that's almost essentially mitigated for at least DDEX or distribution. But some more niche platforms might have some different ingestion schemas. And we're not talking about Apple, Spotify, Tidal. These are major ones that we have, deals and particular teams that will inform us of this before. But there is model drift. That is probably our biggest risk, I would say. Now, there is another one, regulatory constraints. So, probabilistic validation may intersect with intellectual property law. So, some companies we worked with, BMG Rights Management, USA Legal and Trusted Site. We worked with legal team. I was speaking with Rich Beyer from SiriusXM about maintaining compliance, and there definitely are constraints here. So the probabilistic validation, as we're getting it patented, there's definitely some legal gray area. However, for there's some private use, which is where most of our clients are going to be using this, not cross partner, major scale cross partner integration. It's not really going to affect most people. That's why we don't consider it very big. And our third one, like we said again, compute efficiency. So Monte Carlo scaling is very costly. So that's why our 2026 roadmap includes GPU vectorized quasi Monte Carlo and Monte Carlo tree search optimization layers built into our servers. But this isn't really going to be an issue for our clients, as unless mandated by that specific partner, it's going to be sourced on the cloud in our servers. And Michaela from the data governance lead at Atlas Digital Holdings asked, how do we audit the auditors? I'm sorry, Michaela, what do you mean by that? Could you type in the chat an update to that question? Okay, I'll give you a second. Thank you. Okay, you said, how do we audit the auditors? In other words, how does ARDnDeX verify its own probabilistic outputs? We went over this. Meta validation. So every probabilistic forecast comes with, credibility interval and a confidence metric. So, those outputs are themselves validated against historical post hoc results. So over time, we can, compute calibration curves to ensure predictive probabilities, align with observed outcomes. So it's Bayesian honesty. So these feedback loops are really marvelous. They quantify how truthful or our uncertainty estimates are. So based on compiled priors from actual results, not just generated probability outcomes from a simple Monte Carlo. Another question. This is from Horizon Group Equity. It's one of our investors as well. So what is the long-term differentiator of SSO Digital Solutions by 2026 compared to traditional distributors or AI audio firms? Okay. Long-term differentiator. 2026. Yeah, I mean, essentially this is why we're so groundbreaking. Most firms, they're chasing automation. We're chasing explainability. So not just we're just automating this process, which comes with errors and all these other metadata propagators and ecosystems, is that they're if there's a problem, it has to have a human fixing it. Now this system is built to fix itself with the Bayesian models, and every pass, fail, and retry, our core differentiator, I would say, is that everything has a probabilistic justification attached. So by 2026, we're proud to say that SSO will be the first creative tech ecosystem where every data transaction carries a confidence score. So that's going to make our network transparent, defensible, and investment grade. Glad you asked that question. Definitely major pillar in our 2026 plan overall about, just being the first creative tech ecosystem that basically applying justification to validation. That's why our validation network is extremely bounds ahead of pretty much any other company. And this is an academic observer from I think there's a typo in that. I believe it says St. John's. Again, this person did not opt for their name, so we're gonna keep that hidden. But if ARDnDeX were adapted to biomedical data, what modifications would be required? Yeah, we're gonna extend the schema layer. So our schemata is, very flexible. It's not rigid like a simple, single application based API. So it's not just for music like we've mentioned a million times. This is really applicable to any discipline. Yeah, so we could just replace, like, for example, this is a little more simple of what would happen. We have specific teams that, like, with each new, client intake, we're going to build them their own specific, system and implementation setup. But we would replace, like, the MEAD or ERN with a DICOM or I'm trying to think of something that would be applicable to biomedical data, like a DICOM or FHIR structure. But we're going to preserve the same probabilistic core. So Monte Carlo sampling would estimate like uncertainties and imaging metadata. Our Bayesian banded inference loop would flag potential data corruptions before diagnostics from actual like past data. So structurally the validator remains the same. It's only the schemata and priors that change. And the good thing is that we can feed the system priors from any data source, and it translates into YML, and the system is able to parse it. We've seen take a look at our statistics. 13% parsing speed increase. Sorry, that's the wrong thing. Wrong metric. We've seen an 8%. Okay, still 8% parsing speed increase when using a API from our cloud service. So definitely huge. We have actually more biomedical. Okay, so Neural Path Partners, which is more recent of an investor, but definitely Kevin and you've been at multiple of our committee meetings, so you can see that our CertiWave really does allow like blockchain verified audits. So like that ties directly into your question. So your question is are there plans to tokenize or monetize probabilistic compute itself, like offering simulation credits or blockchain verified audits? So yeah, it definitely can be blockchain verified or simulation credit based. But again, the subscription model would fit more clients. We do believe that, but again, not every client's the same, and if there's like a less frequent utilization of the service, it may be more cost effective. So our 2026 initiative, which we internally call Product CertiWave, Essentially, it explores probabilistic proofs on a distributed ledger. So each ARDnDeX run can emit like a cryptographic receipt encoding the simulation seed, posterior hash, and confidence score. So the clients can verify authenticity, without revealing the underlying data. So it's definitely, we're talking medical data, which needs to be, confidential, is not revealed, and it's basically probabilistic computation, meaning like Web3 transparency. So, especially when we implement more features come along 2026, around March time, definitely Project CertaWave is going to be very, very implementable, I would say. So, yeah, great question. Thank you for asking. Okay, so another question. It's coming up. Get to all these questions. Okay. Foresight Analytics Fund. What specific computational frameworks are powering ARDnDEX's inference engine today? CUDA, OpenCL, or custom probabilistic programming layers? Yeah, like I said, it's a hybrid stack. So we do use OpenCL, CUDA, CI, CL layers, CD layers. You know, very hybrid, but we do have custom probabilistic programming layers, since no other tech solution offers what we're rolling out. So yeah, the simulation layer runs on like a CUDA accelerated kernels written in like C++ with we use like the PyMC libraries. That's basically Python's Monte Carlo library. Like style probabilistic inference models for model specification. But the orchestration layer, ARDnDeX core, we used YML and Rust for concurrency safety and deterministic threading. But for reproducibility, we package the environment using OCI containers pinned with a hash lock dependency, so that ensures safety of others' data in our own, framework, while allowing the API key to allow our clients to implement this into their own, projects, services, etc. So it's industrial research, computing, but portable to any partner cloud. Definitely a huge point of making this public facing. Chris Calloway from our committee chair was looking for this question actually. Me and Chris have been talking a lot about the compliance stuff. So in terms of standards, how is the validator ensuring DDEX meet conformance under probabilistic testing? Yeah. So we use stochastic schema validation. So each field within the MEAD payload is stress tested with random perturbations, missing tags, malformed durations, and coding edge cases that we generate from our Sobol sequence Monte Carlo. So if the posterior edge probability exceeds our gating threshold, which is something we have like internal flags built into the schemata, the payload fails before the export. So it's essentially like how do I word this, like fuzz testing with Bayesian awareness. So we're measuring not just like whether it's going to pass, but like how confident we are that it's going to keep passing. So it's not just like a one-time kind of thing. Thank you for asking, Chris. Helix strategic partners. So the question is, Jayden, you have talked about probabilistic auditability. I have talked about that in the last committee meeting. Yes. So how does that translate into regulatory compliance for music rights or medical data? Yeah. So, you can take a look. We're very committed to, standards and different, networks. So we're affiliate of BMI, ASCAP, DDEX committee participant, A2IM member. So we're standing among a bunch of independent labels. We're going to drive innovation, fairness, creative freedom, ISRC metadata planner. So we ensure every release has registered international standard recording code, or more commonly ISRCs. We guarantee accurate tracking, royalty collection, and ownership verification. So we take this very seriously. IFPI, a registered entity. We're in line with the International Federation of the Phonographic Industry, which is ensuring compliant catalog registration and upholding global recording industry standards. And we take user data very, very serious. We're even a member of the National Music Publishers Association, so we're upholding pretty much the pinnacle, or I was going to say highest standards in publishing integrity. So we advocate directly for songwriter rights, fair compensation, and transparent licensing across digital platforms worldwide. So when we're talking about music rights, that is handled. Medical data, we carry the same conviction with that. Extremely, extremely important. We can even say, when a legal audit occurs, probabilistic auditability is going to mean like every validation emits metadata about its own uncertainty. So, let's say for royalties or HIPAA compliance, we can show not only binary pass-fail logs, but continuous confidence metrics. So it's going to satisfy explainability requirements under AU, the AI Act Article 13 and upcoming United States algorithmic accountability revisions. So essentially our uncertainty reports are compliance artifacts. And, compliance for, musical rights, medical data, we're uploading every necessary standard. Great question. Thank you, Helix Strategic Partners. And we have a independent researcher. They say they're part of a computational finance consortium. I'm not sure if that's a company. My apologies, but he's asking, could ARDnDeX's kernels theoretically price complex derivatives or run Monte Carlo variation simulations or VAR simulations? Yeah, absolutely. I mean, look, the math is identical. You replace the metadata fields with the asset parameters, and you get a risk engine. And we've prototyped internal modules using Bayesian, Monte Carlo, VAR estimators of antithetic sampling to reduce variance. And it's not on our public roadmap, but the infrastructure, supports it natively. We're rolling out everything, pertaining to that. And, looking back to what Nova Analytics Funds was asking about, like, the 2026 plan, definitely there. Thank you for asking. But yeah, definitely in the future. Do we plan to? Oh, so sorry. SIC committee member of our neurosystems team. So, do you plan to integrate probabilistic deep learning techniques? Yeah. To reiterate, 2026 plans phase 3 is gonna come around March a little more. It's introducing a Bayesian neural validator into the public domain that it's leading parameter priors directly from previous QC runs, and it's gonna utilize variational inference to approximate high dimensional posteriors, where traditional Markov Chain Monte Carlo becomes computationally expensive. So think of it as like a deep Monte Carlo combining network priors of classical, I don't know how to word uncertainty quantification. Thank you. Looking at Blue Bridge Capital, one of our investors, what's the capital allocation breakdown for the 2026 plan? We're still finalizing the details, but roughly speaking, nothing here is solid, but roughly 40% R&D, so probabilistic engine optimization and GPU infrastructure. That's our server side. Productization give about like a quarter. So we're gonna have SaaS interface subscriptions, CLI modernization and documentation. We already have our technical docs up. Compliance and legal operations give it like another quarter to like a 20%. We're gonna, allocate like funds there to DDEX, DMCA, trusted site, kind of stuff like that. Our different partners, IFPI, NMPA, A2IM, DDEX committee, a lot of other things. Thank you for asking. Yeah, so again, that leaves us with like the rest probably to say strategic partnerships and talent acquisition. So we're just continuing what we do, but by quarter four 2026, we're gonna expect the validator SaaS to reach positive return on investment, driven mainly by like enterprise licensing. So this is gonna be in the public domain. Again, rough, breakdown, not final. And from the AI ethics board, a committee observer, how does ARDnDeX prevent algorithmic bias when priors are data driven? So, we're speaking about this with AI ethics because AI is definitely changing architecture, but we're still discussing it, so we're not so sure fully. But what we've determined is that we every prior distribution is logged, version controlled, and auditable. So like we're enforcing prior transparency. So like if a bias appears, I don't know, for example, like a false positive tendency on like specific I don't know, like language tags, we could trace it to its like prior source and reweight accordingly. So probabilistic systems, they can't hide bias; they just quantify it. So that's like a key ethical advantage, but in terms of AI ethics, that's like a gray area right now. More on that turn quarter two. From Novatech Global, one of our investors, will SSO Digital Solutions pursue external certification of probabilistic AI governance? Yeah, our friend at our AI ethics board just asked. Yes. We were already mapping our validator architecture to like ISO, IC, like the 23 series, so like the 23 894, I believe, or 895. My apologies. The forthcoming AI risk management standard, and collaborating with Adobe Labs, BMG rights management, partially for like third party audit framework. So by 2026, we aim to be the first probabilistic validator certified under that standard with our come 2026 plan. And investor at Quantum Ventures. Any plans to incorporate quantum Monte Carlo methods or quantum hardware acceleration? Yes. Continuously our research is underway. So our quantum Monte Carlo QMC Q under the ARDnDeX infrastructure would let us sample exponentially larger state spaces for metadata and audio feature validation. Once the qubit coherence improves, we're gonna hybridize classical quantum Monte Carlo and quasi Monte Carlo with quantum amplitude estimation for near instant probabilistic verification with API webhooks. And it's ambitious, but entirely in line with our 2030 research track. So research is underway, but at the time, quantum computers and with qubits, like there's a lot of gray area on that as well, and things we don't know. So we're letting things commence with the rollout of quantum computers. But yes, and what's the next leap beyond 2026? How does it evolve into 2030? So our distributed systems committee member, Mike. Yeah, 2030, like the era of like autonomous governance. That's what we believe. So like our probabilistic engines are not gonna only like validate, but they're gonna like self-negotiate within itself. We're trying to edge away from like the hybrid kind of thing. So distributed nodes that are going to adjust like policy weights are going to collectively through like federated Bayesian consensus is that like the idea is that like a self-tuning ecosystem with like uncertainty managed democratically across like every device. So yeah, we're really shifting away from the hybrid system. And I have one last question again from on distributed systems. Thank you, Mike. Says Jayden, thank you for the depth of insight. Any final takeaway for the committee investors today? Thank you. Yeah. I kind of went over everything, but I'm just gonna say that probability is the foundation of like trust. So especially like on a digital validation pipeline, like everything that SSO is building, every validator, audit, distribution, it's a living model of uncertainty. Um, you know, like I said, living model of uncertainty that turning into like confidence. So that's like the heart of our 2026 plan, and definitely like the North Star for like everything beyond. Um, just you know, to wrap it up, I thank everyone for being here. And before we conclude, I just want to extend my appreciation to everyone who joined today. Our technical committee, external researchers at St. John's, investor partners, uh, who continue to believe in what us SSO and SSO Digital Solutions are building. So like what began as like an experiment in probabilistic validation has really become a movement towards computational integrity. So at SSO Digital Solutions, we're not just creating tools. We're pretty much redefining what trust means in digital ecosystems. Validation is like, it's not even the word anymore. It's trust. So the 2026 plan, just to wrap things up, is our commitment to that philosophy. Transforming uncertainty into architecture, randomness into reproducibility, and probability into progress. So by the time ARDnDeX reaches full deployment, it's not just going to validate audio, metadata, or compliance. It's going to validate like any application, whether it be biotech, statistics, finance, whatever. It's going to validate truth, confidence, and transparency into every single domain that it's going to touch. And another word to our investors, thank you for enabling the future of probabilistic infrastructure, and to our engineers, researchers, programmers. Please keep experimenting, keep questioning, keep simulating. And it is really with great gratitude that we really thank you. And everyone listening here, whether you're just listening to the recorded audio, when we're releasing this as just like a podcast, or you're an investor here listening, or whatever, whoever you are, just remember, probability is not the opposite of certainty. It's the foundation of understanding. Thank you, guys. I'm Jayden Reo, and this has been Probabilistic Engines, Monte Carlo Systems, and Applied Bayesian Computing and Digital Solutions. Thank you, guys.